25 didn't go as planned.
535 मार्क्स, बस थोड़े से मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P² CB, जिससे फिजिक्स पे होगा डबल फोकस।
Don't just make it your last try, make it your best one yet. Join Infinity Learn today.
Hello, good afternoon, my dear students. Welcome to one more amazing session from Infinity Line. This is Suresh, Faculty of Chemistry for you. So, you all able to can hear me, can see me? Just give me a thumbs up and fire emoji in the class. So, today we are going to discuss about the chemical equilibrium, some shortcut tricks that you can give you the calculation part of the chemical equilibrium. This session is super awesome. Definitely, I can assure you. In the previous class, we discussed about the fundamental aspects of chemical equilibrium. Students are delighted with that session. Now, on request, the students are requested me continuously in the comment box as well. So, we have to go with a certain numerical based questions in today's class, recapturing what exactly the concepts that are left in the previous class. Are you ready for that? Just give me a thumbs up and fire emoji in the class so that we can start it. Yeah, in the chemical equilibrium, we completed law of mass action and Kc and Kp and the relation between the Kc and Kp, homogeneous equilibrium and heterogeneous equilibrium. And today we will go into how to handle this when it comes to the NEET examination. Students are very good at a conceptual level, but the thing is, you miserably fail when you handle a numerical based on the physical chemistry, isn't it? Yes, from now onwards, it's on us and definitely we can do it. Yeah, hi Mafia. Hi all students. Array, you can say hi to us also, right? So, say hi to Infinity Lane, Mafia. Okay, anyways, NEET examination is completed. Those who already secured rank, congratulations. And those still missed their ranks and you can go for a drop. And today's session is going to be super important for those who are in grade 11, because this chemical equilibrium is from grade 11, and also grade 12, because those who are in grade 12 also, you are going to use the principles of chemical equilibrium in various things, and it is in the journey of NEET. And especially today's session is going to be most important for the NEET dropper. ये NEET dropper strategy है क्या, कैसे करना, everything we discussed in the previous classes, and will be having more strategic sessions in the future as well. And if you have any kind of request, you please let us know in the chat box so that we can schedule a class according to your request. Ready for that? So, before going for the details of the chemical equilibrium, I just want to take you the just small promotion. Infinity Lane by Sri Chaitanya Academy is going to offer you Atreya program. What this Atreya program tells you? It is a NEET dropper program. It is an outstanding program. And once you are just missed your NEET examination, somewhere you are thrown away, you didn't do well in this particular NEET. So, we are going to transform you, that I will do, and crack your NEET examination. Sri Chaitanya Academy by Infinity Lane is going to introduce you Atreya, that is India's most powerful NEET repeaters program. And this is a P² CB. What is this P² CB? And double your practice, physics and chemistry along with biology. Double your practice in the physics. As you know, physics is a nightmare for all the students who are preparing for NEET. Yeah, 2025 NEET examination is slapped like anything with the physics exam. And yes, it should be, if you want to stay good in your competition, you should do physics well. So, it is a problem for the physics for every student and not only you. So, we want to take this physics, we have to come up with some kind of resolution where physics is going to be revolutionary, better preparation. So that is revolutionizing NEET preparation with P square CB, double focus on physics with chemistry along with biology. Dear children, the link is available in the description box. You can click it and you can do the best for it. And what is the course details here? The course is started May 23. Don't worry, every week a new batch is being introduced. So you will be joining in the new batch. So you didn't miss anything. And also the classes will be from Monday to Saturday, and each class is for 90 minutes and there will be 3 sessions in a day. You see how planner is made, so you will be having a less pressure and more result oriented. And also 3 classes per day, which indicates 2 are concept classes and 1 is a revision of what I say practice session. So you are going to practice along with your faculty. So faculty is going to give you the guidelines how to practice it and all. And there are 18 classes per week. In that, double practice class for physics. As I said, physics is a difficult subject. What you feel it, but actually it is not. है ना? आपका परसेप्शन का हिसाब से है फिजिक्स डिफिकल्ट लग रहे हैं ना. सो अगले बार आप नीट एग्जामिनेशन लिखने का वक्त में फिजिक्स इज द फेवरेट टॉपिक एंड फिजिक्स बहुत आसानी सब्जेक्ट होगा. सो आई कैन एश्योर यू दैट. And you can see here the overall picture. There are 465 classes per total package. उसमें 240 DPP सबको दिया जाएगा. So these DPPs are prepared by the content team in such a way that all the models of the questions that are connected to the NEET examination and all physics, chemistry and botany, zoology are included in that. And a dedicated practice session, 120 hours, and more than that you are going to sit along with your senior faculty and you are going to have a discussion, and it is going to be very important. And after the session you can get the notes in the PDF form. And also this is a very important बैच साइज फॉर द प्रैक्टिस क्लासेस 20 to 25, ताकि आपको चांस मिलेगा सीनियर फैकल्टी से डायरेक्ट इंटरेक्ट करने के लिए. So you will be having customized doubt resolution program in this practice session. So you will be having only 20 to 25 students maximum in that batch. So that if you are sitting in 1 in 100 students, no, you can't raise your doubt. But here doubt can be easily accessed. Okay. So and total of NEET syllabus 11th and 12th will be covered here. And my promotion is over. Link is available in the description box. एक बार click करके आप देखना. And also those who completed NEET examination, and you can predict the seat and AIMS, JIPMER, and which college you are going to get, AFMC, any government college, and the top private medical colleges. So find your dream medical college, and the link is available. Just give your details so that we can do the best. So my promotion is over. Let us go into the chemical equilibrium. In the chemical equilibrium, we are going to talk about the reversible and irreversible reactions. The concept is already completed. If you want to go with that and just watch the previous recordings. So आज मैं क्या करना चाहता हूँ, ये concept कैसे इस्तेमाल कर सकते हैं. So you have homogeneous and heterogeneous equilibrium. बच्चों homogeneous equilibrium में क्या होगा, जिस इक्विलिब्रियम में सारे का सारा प्रोडक्ट्स एंड रिएक्टेंट एक ही फिजिकल स्टेट में होगा, दैट इज कॉल्ड होमोजेनस इक्विलिब्रियम. एंड व्हेन यू सी द हेटेरोजेनस इक्विलिब्रियम, यू कैन सी द रिएक्टेंट्स एंड द प्रोडक्ट्स, देयर आर इन अ डिफरेंट फिजिकल स्टेट्स. Okay, so there you have seen active mass and everything, and you have various types of active masses. Okay, yes. Here you can see the chemical equilibrium. The chemical equilibrium is a state where the rate of forward reaction is equal to rate of backward reaction. So, when you talk about A plus B gives rise to C plus D, okay. So, A is converted into B and A plus B gives rise to C plus D and A plus B gives rise to C plus D. These are the reactants and the products. So, the change in concentration with respect to time is called as a rate of reaction. So, as the reaction goes on, so the rate versus time a graph is taken. So, as the rate versus time, you are going to see the forward reaction rate decreases with respect to time and the backward reaction rate increases with respect to time. And in that, there is a situation where rate of forward reaction is equal to rate of backward reaction. This state is called equilibrium state. This state is called equilibrium state. My dear students, I strongly recommend who are there in the online right now, you please click the like button, and if you have any doubts, and please ask in the chat box, and you can have a kind of discussion and take a pen and paper and can have a directional discussion between you and me and write a noteworthy point, so that is going to be a quick revision program for you, right? So, the rate of forward reaction, rate of backward reaction we can say. So, what is the rate of forward reaction? Rate is going to be, forward reaction is equal to Kf and the concentration of A and the concentration of B. Similarly, rate of backward reaction is going to be, you have to check in this direction. So, it is Kb and C and D. And at the situation, rate of forward reaction is equal to rate of backward reaction, है कि ना? And ये दोनों का rate क्या करना? Okay, Deepanshu, Radhe Radhe. Okay, that's good, very good. Whenever you just put a message in the chat box, na, that session is going to be live interactive session. Otherwise, we feel this class is going to be radio type session. Even I feel it is very boring. So, you make the class awesome and aggressive. So, rate of backward reaction is equal to rate of forward reaction. ठीक है बेटा? So, उसमें क्या होगा? Rate of forward reaction, उसमें Kf is equal to, मैं यहाँ पर लिखना चाहता हूँ, Kf is equal to A and B and Kb is equal to C and D. Okay, right. Now, you can see Kf and Kb. So, Kf upon Kb is equal to C and D and A and B. So, these are the जो इसमें स्क्वायर ब्रैकेट में लिखा हुआ ना, ये एक्टिव मास होगा. Okay, now you can see this is a rate constant and divided by this is another rate constant. ठीक है? So, the ratio of this rate constant is going to be another constant that is called K equilibrium. So, K equilibrium is the ratio of the rate constant to the rate constant of backward reaction. And this is called law of chemical equilibrium, that is given in this expression. मान के चलो ये वाला A moles of A, B moles of B, C moles of C and D moles of D. And you are going to see the equilibrium constant C moles of C, active mass of C to the power C, and active mass of D to the power D, and upon active mass of A to the power A, active mass of B to the power B. So, capital A, B, C, D are the active masses of the reactants and the products, and small a, B, C, D are the stoichiometric numbers. The number which is used to balance the equation is called a stoichiometric quotient, and this square brackets indicates that is an active mass beta. And you can see writing the equilibrium expression, that is very important. So, 4NH3 gas, 7O2 gas and 4NO2 gas and 6H2O gas. And simply I am going to tell you to write the equilibrium expression, product divided by the reactant or the important aspects. So, you can see the product NO2 and here the 4 number is given, that is the 4 number here, understand. Here H2O and 6 number is given, that is the 6 number, to the raised to the power terms of this active mass, my dear children. And NH3, 4 number is given, here it is going to be again 4 number. Here oxygen, 7 number is given, here it is going to be the 7 number. These are the stoichiometric numbers. This is how you write it. And at equilibrium, we already discussed this, characteristics of the equilibrium. That's very important. इसका हिसाब से आपका नीट एग्जामिनेशन में एक क्वेश्चन निकालने के अब संभावना है. Which of the following is true? Which of the following is not true? Ready? So I just want to conduct, after this I want to conduct a quiz and mentees also, and also I want to take a quick rapid revision multiple choice questions based on each chapter. So we are right now in a Nirman series where we are preparing the students for the NEET 2026. So those who are in grade 12 and those who are dropped from grade 12 and take a drop for a year writing a NEET examination 2026 can get the benefit of this today's session. Of course, today's class is about the topic which is picked from this grade 11. So those who are in the grade 11 also can attend and get the benefit of this. And to have this kind of sessions, you need to go to a coaching center or any coaching center where you have to pay a huge amount of money and you have to travel a long way. And here we are providing these sessions on the YouTube platform for the free of cost. You need not have to pay anything, so that take advantage of this. So please attend the session without any failure. And this series of session kab kya class kab hoga, so you please press the bell button so that you are going to have the session updates as well. So my dear children, please like this session and share with your friends, because इन लोगों को भी फायदा होना चाहिए. Please subscribe to Infinity Land NEET YouTube channel. So let us go ahead with this. So characteristics of a chemical equilibrium. Chemical equilibrium is dynamic in nature. कहीं रुकते नहीं. So you feel it is stopped, but it will not be stopped. Although reaction is to be stopped, but it takes simultaneously both forward direction as well as a backward direction. That's very important. And also to obtain equilibrium, bachcho, and if any one of the reactant is the product in the gaseous state, so ये reaction container में निकालने का कोशिश करते हैं, so that we have to use a closed container so that the gas is not escaping out. So the equilibrium is attained in the closed vessel if any one of the reactant or the product are there in the gaseous state. Understand? Clear? And also at a given temperature and pressure equilibrium, the properties like measurable properties like you can say color, density and viscosity kind of things, concentration are always remain constant. At equilibrium, measurable properties are going to be constant. Okay. And also in a reversible chemical reaction, the equilibrium state, so catalyst is used to reach the equilibrium state. Equilibrium जल्दी पहुंचने के लिए इस्तेमाल कर सकते हैं, लेकिन equilibrium state का direction decide करने के नहीं. So catalyst has no influence on the state of equilibrium. Rather, the catalyst is used to reach the equilibrium so quickly and soon, right, bachcho? So like that, you see, you can say if catalyst is used, you can say equilibrium is increased. No, that's a wrong perception. That's a wrong perception. And also at catalyst doesn't change the equilibrium state because it increases the rate of both forward reaction as well as a backward reaction. ठीक है बेटा? And this is a very important points that are based on the characteristics of equilibrium. अगर कुछ doubt है ना तो पूछना बेटा. And Dipanshu, come on. Dipanshu, yes. Now you can see, let us see, this is an ester hydrolysis. In order to prevent the escape of the product, equilibrium reached only in the closed vessel. I already mentioned better. And you can say homogeneous equilibrium, in which the reactant and the products are in the same phase. Iska ester hai na, it is hydrolyzed to give an acid and alcohol. You can see this is in the liquid state, this is the liquid state and liquid state. That is called homogeneous equilibrium. Homogeneous equilibrium has the same physical state. Okay. and you can say heterogeneous equilibrium. Heterogeneous equilibrium में different physical states are there. Heterogeneous equilibrium, you can say solid gas, different physical states are there. Are you getting or not? Dipanshu, writing the things? Okay, fine. You can ask doubts now. If you ask doubts, you can just chart, we can have a kind of discussion. ठीक है Dipanshu, I am really a friendly teacher and I'm encouraging the student to be interactive here. Okay, be interactive. Next, so this is a noteworthy important point, beta. Whenever the question doesn't ask about the direction, then we take the forward direction only. क्वेश्चन में आपको कैसा पता चलेगा? इफ नथिंग इज आस्क्ड अबाउट द डायरेक्शन, मान के चलो ये आगे बढ़ना फॉरवर्ड रिएक्शन मान के चलो, एंड इन ए रिवर्सिबल रिएक्शन द फॉरवर्ड रिएक्शन, अगर फॉरवर्ड रिएक्शन एक्सोथर्मिक होगा तो ए बैकवर्ड रिएक्शन एंडोथर्मिक होगा एंड वाइस वर्सा. अगर फॉरवर्ड रिएक्शन एंडोथर्मिक होगा तो बैकवर्ड रिएक्शन एक्सोथर्मिक होगा, फॉरवर्ड रिएक्शन एक्सोथर्मिक होगा तो बैकवर्ड रिएक्शन एंडोथर्मिक होगा, है ना. दैट्स अ वेरी इंपॉर्टेंट पॉइंट. And also you can see types of equilibria. You have physical equilibria where you are going to see the physical state change. The phase of the state is going to be changed. It is going to be equilibria. And following types of common physical type of equilibria, you can say liquid vapor equilibrium. You can have a liquid vapor equilibrium. You can have a solid liquid equilibrium. You can have the solubility equilibrium as well. सॉल्युबिलिटी कब होता है? जब सोल्यूट सॉल्वेंट में डिजॉल्व करते हैं ना, उसमें सॉल्युबिलिटी होता है. सो बेस्ड ऑन दिस यू कैन हैव सर्टेन रूल्स लाइक हेनरीज लॉ एंड एवरीथिंग. वी जस्ट गिव ए शॉर्ट इनसाइट ऑफ दिस एंड देन आई एम गोइंग टू show you how the problems can be solved by step. Okay, now you can say gas solvent equilibrium, you can say liquid vapor equilibrium. So the liquid is evaporating, that is called evaporation, and this is called condensation at this equilibrium. You can say liquid vapor equilibrium. You are in 11th. Very good. आपको जो बहुत फायदा होता है दीपांशु यादव. कहाँ से आप? Okay, and you can say सॉलिड लिक्विड इक्विलिब्रियम. जब आप आयोडीन सॉलिड है ना, ये हीट करने तो सब्लिमेट करते हैं, सो वेपर्स ऑफ आयोडीन इज गोइंग टू बी कंडेंस्ड हियर. सो देयर इज एन इक्विलिब्रियम बिटवीन द सॉलिड आयोडीन एंड द वेपर आयोडीन, sublimation equilibrium, you can say that. So you can see camphor also comes under this category. Okay बच्चों, एंड यू कैन सी सॉल्युबिलिटी इक्विलिब्रियम. जब सोल्यूट वाटर में ऐड करते हैं, सॉल्वेंट में सोल्यूशन बनाते हैं. जब सोल्यूशन बनाने के वक्त में अनसैचुरेशन होगा पहले. ओके, उत्तर प्रदेश से. गॉड ब्लेस यू बेटा. ओके, भगवान अच्छा करेगा. एंड यू फॉलो आवर लेक्चर्स एंड टेक इंपॉर्टेंट नोट्स. ठीक है बेटा. And once this solute is completely dissolved in it, there is going to be a deposition of the undissolved salt. So there is an equilibrium between undissolved salt and dissolved salt. That is what is called as a saturated solution. That's very, very, very important. So NaI in the solid, Na plus and I minus, and in the water there is an equilibrium between the undissolved salt and dissolved salt. This is what is called as a solubility equilibrium. Now you can say when the gas is dissolved in the water. So gas water में liquid में कैसे dissolve करते हैं? Take an example of any cool drink. So the carbon dioxide is the gas is dissolving in the liquid water. So there is an equilibrium. So gas is dissolved in the liquid. अगर pressure बढ़ते जाओ ज़्यादा gas dissolve करना का. So that is explained on the basis of Henry's law. Henry's law says solubility of gas is directly proportional to the pressure of the gas. Okay, you can say pressure of the gas is directly proportional to mole fraction of a gas. Mole fraction is the function of solubility. अगर solubility बढ़ते जाते हैं and mole fraction of the gas in the liquid also increases, that is called as a P gas. Okay, is equal to Henry's law constant and mole fraction of a gas. Absolutely important. KH is called as Henry's law constant. This Henry's law constant is a constant. अलग अलग gases को अलग अलग KH values ज़्यादा होता. And you can see for a given gas, the KH value is a constant at a given temperature. What happens, you know, a gas with higher solubility will have the lower KH value. So that is explained. Definitely we are going to see these kind of things more vigorously in the solubility and solutions, and for the equilibrium we just want to give it here. Okay, so now this is the Henry's law I already mentioned here. So solubility of the gas is directly proportional to its pressure. ठीक है, अगर कुछ डाउट है ना तब पूछना. दीपांशु, दीपांशु, yeah, hey, yeah, mafia, right. So chemical equilibrium, you can write the chemical change. Law of mass action, we already discussed this, and we'll see some more things over here. Yeah. This is a very important point. I don't want to derive this, the relation between Kc and Kp. You have equilibrium constant here, bachcho. Equilibrium constant is called Keq, is of various types. One is called Kc, another one is called Kp, and the other one is called Kx. Kc is equilibrium constant in terms of concentrations. Rajeshwari, hi. So no internal discussions among you, short decorum maintain karna beta. So you can have a discussion with me and you can see Kp is called equilibrium constant in terms of partial pressures. जब आप एक्टिव मासेस जो है ना मोलर कॉन्सेंट्रेशन इस्तेमाल करो Kc होगा, so partial pressure इस्तेमाल करो Kp होगा, and you can say Kx. So Kx is the equilibrium constant in terms of these mole fraction. So UP से हो क्या 999. Okay, so no other discussions, only academic discussions permitted में chart box में. So how the Kc and the Kp are related? So here Kc and Kp are related. Kp is equal to Kc RT to the power delta n. उसमें delta n क्या होगा? If you remember anything, you just let me know. So delta n होता है आपका very important. It is in the gaseous state, is going to be sum of the number of gaseous products minus sum of the number of gaseous reactants. If it is a liquid and solid is there, you don't consider it. Only gaseous systems का पकड़ना है. Okay, now let's see. So here we know that Kp is equal to Kc RT to the power delta n. अगर कोई रिएक्शन का डेल्टा n वैल्यू 0 होगा तो सो पॉसिबल वैल्यूज मैं बता देता हूं. सो Kc Kp वैल्यू पकड़ के हम क्या कर सकते हैं? If the reaction K is equal to 1, K is greater than 1, K is less than 1. I want to take you 3 expressions here, 3 graphs over here for the concentration with respect to time. We just see here concentration with respect to time and concentration with respect to time. Here concentration. So मान के चलो यहाँ पर अगर ये B को दे सकते हैं ना, now you can see ये gives rise to B and B gives rise to A. This is a reversible reaction. Okay, okay, no problem, beta, no problem. You see, the graphs in the physical chemistry are very, very important. So, A gives rise to B. So, the concentration of A decreases as the time proceeds. So, concentration of B increases as time proceeds, and concentration of A decreased, concentration of B increased. Now, the concentration remains constant. So, this is going to be state of equilibrium. At state of equilibrium, concentration of A is equal to concentration of B, ताकि इसका K value 1 होगा. So, this is the situation. You understand? When the concentration with respect to time, if a concentration of A is decreased and concentration of B increased, this is the concentration of A and this is your concentration of B. So, what I want to say, the concentration of A is less than concentration of B. So, product is more formed. So, that K is greater than 1. K is greater than 1. That's very good. That's very good. When you see here, concentration of A is like this, concentration of B is like this. So, concentration of A, B se zyada hoga. So, the reaction is not favoring more in the forward direction, rather it is backward direction is formed. So, it is going to be K value is less than 1. So, these are the various conditions you can say by using these graphs as well. So, understanding the graph is a key point in physical chemistry. So, definitely in the 2025 also and 2024 also, there are a very good number of questions that has been asked in the NEET examination based on the graphical interpretations. When it comes to the graphs, you can say chemical kinetics is very important for graph based questions. Then it comes to the equilibrium, then it go with the thermodynamics as well. So, stay tuned with our sessions. I am going to present you very good number of lectures along with the graphs. Total graphs के लिए भी एक session बनाना चाहता हूँ, है ना? And stay tuned. That's the reason why please like this session and subscribe to NEET Infinity Learn YouTube channel. So, here we were producing here. If as a K value increases, stability of the product increases and stability of the reactant decreases and time to equilibrium to reach the equilibrium decreases, and this is a noteworthy point. Everybody take a snapshot of this particular slide and take a note of this. 3, 2, 1. Do it. So, click it. One thumbs up in the chat box. You have taken this, Dipanshu, right? So, here stability of the reactants in the products, you can see it's a question, it's a hypothetical question, imaginary equations that I have given you, okay, imaginary reaction I have given you. So, XO gives rise X2 plus O2, iska Kc value 10 power 24 ka hai, okay, and XO2 gives rise X2 plus O2, iska Kc value. So, this Kc, you can see here the last statement, as K value increases, stability of the product increases. You understand? And iska K value, iska XO2 and XO. So, that you can say the reverse you can say. When you talk about the reverse, it is going to be 10 power minus 24 and 10 power minus 10. So, XO2 का K value ज़्यादा है, formation of XO2 का K value ज़्यादा है. Are you getting or not? So, that among XO and XO2, XO2 is going to be more stable. Are you getting or not? So, reverse करके लिखो, X2 plus O2 gives rise XO. So, इसका K value is going to be 10 power minus 24. इसका X2 plus 2O2 gives rise to XO2, okay. So, इसका K वैल्यू आता है 10 पावर माइनस 10 का. से दोनों में कौन सा वैल्यू बड़ा है? दोनों में कौन सा वैल्यू बड़ा है? ये वैल्यू ज़्यादा दिख रहे हैं, ताकि इसका XO2 का स्टेबिलिटी ज़्यादा होगा. Are you getting or not? So like that, simple logical questions will be there in the equilibrium from the NEET perspective. And the key point for this is going to be this. Key point for this is very important. ठीक है. And आगे बढ़ो. For reactant, stability increases when the K value decreases. For the product, stability increases when the value of K increases. And more is the value of equilibrium constant, more is the formation of products, means more is the stability of the product. This is an important point. बच्चों समझ में आ रही क्या दीपांशु? सर 12th का क्लास कब होगा प्लीज बता दो. सो 12th का क्लास भी ये सीरीज में चलेगा बेटा. एंड कौन सा टॉपिक चाहिए 12th को जल्दी बताओ, मैं अगले सेशन में स्केड्यूल करना चाहता हूँ. टॉपिक आप बता दो. ओके, नाउ यू कैन से हियर फाइंड द वैल्यू ऑफ Kc फॉर द फॉलोइंग इक्विलिब्रियम विद द Kp वैल्यू इज गिवन. Kp दिया, you can say, so here Cl gives rise to NOCl gives rise to NO plus Cl2. Kp value is given 1.8 into 10 power minus 2, है ना. You are asked to calculate, sir class 11th का है भी, हाँ, and you are asked to calculate Kc. We have the Kp is equal to Kc RT to the power delta n, है ना. So Kp दिया गया and Kc पूछना है. So chemical thermodynamics chapter, okay, that is in the grade 11, not in the grade 12. Mole concept is completed better Dipanshu. You can watch the recording. You want me to say one more practice revision, I can conduct it. Okay, right. So for this, if you have a delta n value product 2 plus 1 is equal to 3 minus 2 is going to be plus 1. So physics units and measurements, physics class आज chemistry class का है ना, physics class कल होगा. Okay, so we can study that. Okay, anyways, Kp is equal to KcRT to the power delta n. So delta n is already calculated. You can say Kc is equal to Kp by RT. So Kp is given 1.8 into 10 power minus 2. R value 0.0821 is taken and 600 Kelvin temperature is also given. When you simplify, this is going to be 3.65 into 10 power minus 4. So it is very, very, very important. So this is the steps I am following now. You follow the same steps so that you can do the best. है ना? And also find the value of Kc for the each of the following equilibrium. CaCO3 gives rise CaO plus CO2. Kp is given. And you can say Kc value कैसे calculate सकते? Kc value is equal to, you can see, so Kp is given 167 and delta n is equal to, it is taken as a 1, it is taken as a 0 because it is a solid and it is taken as a 1. Okay, it is going to be and delta Ng value is going to be here, Kp is equal to Kc RT to the power delta n, and you can say Kc is equal to Kp by RT, it is 167, 0.0821 into 1173, its temperature is given 1173, it is going to be 1.732. Okay, and factors affecting the equilibrium constant, it is very important. So factors affecting the equilibrium constant. So if the direction or mode of representation of the reaction. So A plus B gives rise C plus D. The equilibrium constant Kc is written as C and D and A and B. That is the way you represent. If you change, if the reaction is reversed, if this reaction is reversed, A plus B gives rise to C plus D, na? C and D and gives rise to A and B, right? So you are going to see Kc dash is going to be reversed A and B upon C and D. So what's the relation between this and this? अगर Kc उल्टा करेंगे तो Kc dash मिलेगा, right? So that we can say, and that we can say the two equilibrium constant is related as Kc is equal to 1 by Kc dash. That is very important. Like that we can do some questions based on this. Okay, clear? And also for N2 plus 3H2 gives rise to NH3 if Kc is 5. You find the Kc dash for the reverse reaction. Who is going to tell you this? Who is going to tell the answer? So make it fast. So simply Kc dash is equal to 1 by 5 because the reaction is reversed and Kc value is given 5, and yes, you have to reverse this. You are going to give 0.2. And stoichiometry of the reaction. Stoichiometry of the reaction is also very important. So when a reversible reaction can be written with the help of 2 or more stoichiometric equation, the value of equilibrium constant will be numerically different. How it is possible? Let's say here NO2 reversibly gives N2 plus O2. Okay, Kc value is given N2O2 square upon NO2 square. If I want to make it half, so divided by 2. So NO2 gives rise half N2 plus O2. So you are going to get Kc dash. So that is given by N2 to the power 1 by 2 and O2 to the power 1 upon NO2. Right? So how this and this is related? So if you take this is a square, if you take this a square, so you are going to get Kc dash square is going to equate to Kc. I could say that Kc dash is equal to root over Kc. That is what it is mentioned. And this is a very, very important. This is a very, very important. Okay, it is useful for NEET examination. It is useful for NEET examination. अगर कुछ doubt है ना तो पूछना जल्दी. And this is only the things you have to focus. And we'll writing expressions for various degree of dissociation also we are going to do it. So, bachcho, you like it? You like it? Dipanshu or all the students who are there in online, please like the session and give a thumbs up and fire emoji in the current right now so that we are going to move ahead. Okay, bachcho, jaldi batao. And the temperature, yes. So, like mara session ko. Those who are in online, please press the like button. Yes. Now you can see the temperature. So, if the temperature increases, the rate of reaction definitely increases. मान के चलो at temperature T1 equilibrium constant K1, temperature T2 equilibrium constant K2. ये K1 K2 and T1 T2 कैसे relate कर सकते हैं? हाँ, you can relate by using a want-Hoff equation. This is your want-Hoff equation. That is given as, for your convenience sake, I just want to say log K2 upon K1 is equal to delta H, enthalpy of reaction or heat of reaction, 2.303 R. So, T2 minus T1 and T1 into T2. So, this expression is called as a want-Hoff equation. अगर K1 and T1 में देते हैं and at T2 K2 कितना होगा and delta H भी दिया जाएगा. Okay, so everything you can do it based on this, and the similar kind of equation you can see in the chemical kinetics and Arrhenius equation का application भी उसमें आ जाएगा. Okay, just take a snapshot everybody, screenshot लेना जल्दी जल्दी जल्दी. लिया? एंड आगे बढ़ना. ठीक है. नाउ इफ डेल्टा एच इज इक्वल टू 0 मीन टू से जैसे रिएक्शन में हीट नहीं देता है नहीं लेता है, so thermoneutral reactions, neither heat is absorbed or evolved, then log K2 minus K1 is equal to 0, so K2 is equal to K1 and the temperature has no influence on that kind of equilibrium states. okay, remains the same, rate equilibrium constant remaining same, and I would say kind of this, a temperature independent for this. Now you can say for when delta H is going to be positive, so I mean to say heat is entering into the system endothermic process. In this endothermic process, delta H is going to be positive beta, so that log K2 minus K1 is greater than 0. अगर टेम्परेचर बढ़ते हैं ना K2 is greater than K1. So I would like to say as the temperature increases, the rate, the equilibrium constant value is going to be increased. Reaction favors more in the forward direction. So ये logic आप ली Chatelier principle में इस्तेमाल किया जाएगा. ठीक है बेटा. And when delta H is going to be negative, that is going to be exothermic process, the heat is released. So log K2 minus K1 is less than 0. Endothermic reaction मतलब क्या, जिस reaction में heat is absorbed, endothermic होगा, and heat is released, okay, that is called exothermic होगा. So log K2 minus K1 is less than 0 and the log K2 is less than K1, and it is going to be K2 is less than K1. Are you getting or not? And the value of the equilibrium constant is going to be decreased as temperature is increased. So Kc is inversely proportional to the temperature here. And also you can say the value of equilibrium constant independent of the following factors. And the statement based questions NEET examination में multiple choice questions ऐसा निकाल सकते हैं. Yeah, so it is initial concentration. Equilibrium constant is independent on the initial concentration, rather it is dependent on the equilibrium constant, equilibrium concentrations, and also presence of a catalyst. Okay, and if catalyst is used, Kc value बदलते नहीं, and also the direction from the equilibrium has been attained. Okay, so and also it depends only on temperature, presence of inert materials, also it is independent, mind it, it is independent. Okay, and now we can say E plus F gives rise G plus H. Okay, and if we start with 6.0 moles and 7.0 mole of F, 6.0 mole of E and 7.0 mole of F, and 1 liter vessel, the equilibrium is attained, okay, and 4.5 mole of G is formed. Calculate the value of equilibrium constant. Okay, so this is the kind of questions you are going to expect. I will show you how to handle this kind of problem. E plus F gives rise to G plus H. Now, initially time is 0, it is given as 6, and here it is given in 6 and 7, and 4.5 is formed. So 4.5 is formed means you can say 6 minus 4.5, 7 minus 4.5, and it is going to be 4.5, and if it is 4.5 is formed, it is also 4.5 is formed, because 1, 1, 1 and 1. So 6 minus 4.5 is going to be 1.5, 7 minus 4.5 is going to be 2.5. So आपको मिला equilibrium constant. When you got the equilibrium constant, Kc is going to be taken as number of moles per liter. Number of moles per liter upon number of moles per liter आपको मिलेगा 5.4 is the answer, right? Dipanshu, this is one way of handling the questions. One way of handling the questions. Is this visible? Now let us see one more question. The equilibrium constant Kc for the reaction is given. Okay, what is equilibrium constant Kc for the reaction between H2 and I2 is given? 57 is given. Okay, and if 1 mole of H2 is allowed to react with 1 mole of I2 in a 10 liter vessel, okay, in a 10 liter vessel, okay, what are the concentration of H2 and I2? So H2 and I2, right? At equilibrium, what is the composition of equilibrium mixture? Everything is given. So how to handle this kind of problems? How to handle this kind of problems? So you need to have a flow chart to do that. Let me tell you. So steps to follow to have the questionnaire. So first step is write the balanced equation. So write the balanced equation for the reaction, so that it is going to be H2 and I2 and gives rise to HI. है ना? And the second step is, under the balanced equation, make the table of a list of these initial and change in concentration, equilibrium concentration. So it is given as 1 mole of H2 is introduced and 1 mole of I2 is introduced, okay, and it is going to be 0. So let us say 1 mole of H2 से X निकल गया, 1 moles of I2 से X निकल गया, is going to get 2X. Are you getting or not? Then the Kc is written as 1 minus X by 10 liters, because it is the 10 liters, 1 minus X by 10 liters, it is going to be 10 liters. So you can say Hi square and H2 and I2, okay, and Kc is given as 2X upon 10 square and 1 minus X and 1 minus X, that is equal to 57 is given. So you can solve X na, quadratic equation निकाल के, समझ में आ रहा है क्या? That's very important. That is what it is explained. And substitute the equilibrium concentration into the equilibrium equation. For the reaction to solve the X, you have to take a quadratic equation, you can solve it. Are you getting or not? And this flow chart is very, very important. If you must solve the quadratic equation, choose the mathematical solution for the make the chemical sense. You can have the positive values and negative values, so take the positive values, okay, and the calculate equilibrium concentration from the calculated value of X you are going to get it, and also check your results by substituting into the equilibrium equation again if you want to recheck it again. And like this you can solve this. So 1 1 0, 1 minus X and minus X, and is going to be 2X, the previous questions ka hai. And it is going to be equilibrium concentration, it is going to the molarities, and put it in the Kc. 57 is equal to 2X square upon 1 minus X square, okay. And on doing the notes मिलेगा, हाँ telegram channel में मिलेगा Deepanshu, okay. And on solving X you are going to get as, yes, on solving X is going to be by using a quadratic equation, you are going to get 0.079 molar, and you can put it there again, okay, and you are going to get X value बना के आपको 57 के इक्वेट करो, कंपोजिशन ऐसा कैलकुलेट करना के ज़्यादा संभावना में मिलेगा. And to solve this chemical equilibrium calculation इतना लंबा दिखता है ना, नीट एग्जामिनेशन में इतना लंबा नहीं आएगा, एक ही क्वेश्चन में इतना सारा कैलकुलेशन रख के आपको all the varieties of models are covered here. Yeah, Deepak Kumar, hi. Deepak, hello. So you like the session? So Ram. Now let's talk about, so this is an important point. Everybody take a screenshot of this. Everybody take a screenshot of this. Everybody take it. Screenshot liya? Wonderful. Deepak, Deepanshu, and now I just want to take some other important aspects. Extent of equilibrium, the equilibrium constant. So extent of reaction equilibrium constant, yes. So If you like this session, just see the number is increased. Thank you, Deepak Kumar. Right. So, extent of reaction and equilibrium constant. So, the equilibrium constant देख के आप बता सकते हैं आप reaction का direction क्या होगा. Reaction का direction है, if the equilibrium constant is less than if the equilibrium constant is less than 10 power minus 3, reaction favors in the backward direction. If the equilibrium constant is greater than 10 cube, the reaction favors in the forward direction. If the equilibrium constant 10 power minus 3 and 10 cube बीच में होगा तो reaction, forward reaction and backward reaction दोनों भी चलता रहता है उसमें. Okay, this is very important and this is a noteworthy point. Everybody can take it. Dipanshu. So, of course, at the end of the session in the Telegram channel, YouTube Infinity Learn Telegram channel is there and the link it is there in the description box. You can just click it, Dipanshu, and join in the Telegram channel, so that in the Telegram channel हर दिन डेली क्विजेस मिलेगा. ये हमारा जो सेशन है ना, सेशन का नोट्स भी आपको मिलेगा एंड सेशन अपडेट्स भी आपको मिलेगा. Dipanshu, are you getting or not, everybody? And let us say here concentration. Okay, we already given this. Okay, talking about reaction quotient. Reaction quotient. So what is the meaning of a reaction quotient? It is the ratio of the active masses of the product upon reactant. And what is this? It is equilibrium constant. Kc का जैसे है ना, and Kc and Kc are so same, but Kc is only recorded at the state of equilibrium, बच्चों. But QC reaction quotient can be recorded at any time. Okay, if Kc is equal to QC, so you can say this is, if Kc is equal to QC, the reaction is said to be at equilibrium. A very important point. You can use this Le Chatelier's principle, direct implementations of the QC. And if Kc is greater than QC, then the reaction favors is going to be more in the forward direction. And opposite, you can say, if Kc is less than QC, then you can say reaction more favored in the backward direction. And you can say here, yes, this the pictorial representation can indicates you the direction of the reaction, bachcho. Here Kc is equal to QC, reactants and the products are in the equilibrium. You can say A gives rise to B and B gives rise to A and equally. And you can say QC का value कम है, Kc का value ज़्यादा है, so that reaction हमेशा आगे बढ़ने का कोशिश करता हूँ, and this is going to be least favored in the backward direction. If QC is greater, so that A gives rise to B, this forward reaction is very less and the backward reaction is going to be more. And this representation can indicate this is a very, very important. And based on this NEET examination, you are going to have a question based on this. So you can have, so a mixture of 4.2 moles of nitrogen and 2.0 moles of hydrogen and 10.0 moles of ammonia is introduced in a 10-liter vessel. Okay. So this, at this temperature, the equilibrium constant is given 1.7 into 10 square. Okay, this is the Kc value. Kc value is given as 1.7 into 10 square. Now the question is the reaction at equilibrium? We have to tell whether the reaction is at equilibrium. If no, what is the direction of equilibrium, we can say. Now nitrogen concentration 4.2 na, 4.2 divided by 10.4, and hydrogen na 2.0 upon 10, 0.2, ammonia 10 by 10 is equal to 0.1. So directly put that in the equilibrium constant. This concentration you can calculate in the QC. When you write the QC, NH3 square upon N2 and H2 cube, and when you put it, you are going to get 2.9 into 2.976. So मेरे को लग रहा है ना QC is less than KC. KC का value दिया गया 10 square. okay. So that Kc is going to be greater, so reaction favors in the forward direction. So since this value, so Kc, the reaction will proceed left to right, reaction favors in the forward direction. So this is the interpretation you can say. Are you getting or not clear? Are you getting or not clear? And some more handwritten scripts are there. I just want to show you. Some more handwritten scripts are there. 1 minute. Here you can say the equilibrium, a beautiful level of expressions are there. You can see here. When evaporation takes place, H2O liquid is evaporating and it is a liquid vapor equilibrium. It is going to, the equilibrium is established. Water is evaporated and it is condensed into the liquid state. And this graph you can see, the H2O liquid concentration decreased and H2O gas concentration is increased, and it is the concentration is not changing with respect to time, and this is the state of equilibrium. Understanding the graphs is important, and you can say the equilibrium concentrations have changed. The equilibrium is established more quickly. In this case, it is coming to be down and it is going to be up. At equilibrium, there is a greater amount of H2O gas as more has evaporated at the higher temperature. So if the temperature is increased, it is going to be like this. So this is going to be forward reaction is more favored in this way. Understand, bachcho? Clear? And also, if you talk about this, the forward reaction is less and the backward reaction is more. So you can see the equilibrium state, liquid water has more concentration as compared to this water vapor. So K is less than 1. The position of the equilibrium has shifted to the left as this lower temperature. This happens at low temperatures, this happens at high temperatures, and this happens at the ordinary temperatures. Are you getting or not? So these graphs can give you very good picture about what you understand. This graphs enhances your understanding ability. Deepak Kumar and Dipanshu, hope you like this. And you can see this is at a low temperatures and how to write the Kc and Kp. And the Kc is equal to products to the power A and the reactant to the power B, and here the power A concentration is raised to the power of the coefficients in the equation that you use, balanced chemical equation. And here B, it is said that square brackets denote this concentration, and also you can say H2 plus I2 gives rise to HI. आप कैसे लिख सकते? Kc is equal to HI square. Concentration at equilibrium must be determined experimentally. You can't look at that and you can say that, right? And always include the state symbols in the expression for the Kc. You have to use this state of the matter, otherwise it doesn't give the meaning. So very good important points I'm telling you, bachcho. You can see N2 plus 3H2 gives us 2 NH3. Up Kc ka value, Kc is equal to NH3 square upon N2 H2 cube, and Kc, you can see the dimension, mole dm cube, mole per dm cube square upon mole per dm cube into mole per dm cube per cube, and on doing so you are going to get mole per dm cube to the power minus 2, and expand you cannot cancel out, right? You can cancel out. What did you say? I want to say mole per dm cube to the power delta n is the equilibrium Kc unit. So that you are going to get the same thing, mole square dm to the power 6. Simple na? So positive unit gives before the negative. You can write like this also. Ha. Okay. Now you can see the dimension of the Kp is equal to pressure atmosphere to the power delta n, or Kc is going to be mole per liter to the power delta n, or mole per dm cube to the power delta n. 1 liter is equal to 100 dm cube. Okay, Dipanshu, fine. Now you can see, so this is the question I just want to indicate here. It was determined CO plus Br2 gives us CO Br2. This is an equilibrium expression. Okay, and it is determined by the equilibrium concentrations. CO2 का दिया, Br2 का दिया, CO Br2 का भी दिया, and you are asked to get calculate Kc. Who is going to do this calculation first? Take care, Sarfaraz. Yeah, Dipanshu, you can directly write the Kc expression for this. Kc is equal to CO Br2 upon CO and Br2. Always start writing the expression for Kc. This is a simple technique I want to give you. Right? And when you have given CO Br2 ka value and CO ka value and Br2 ka value, by doing simple mathematical calculation, you can say it is 94.1. Remember, work the units. NEET examination, units में भी काम करना पड़ता बेटा, units में भी काम करना पड़ता. If the same value is given, who is going to look at the units? ठीक है, fine. And this is another expression. Another one before you complete the before we complete the session. So for an equilibrium PCl5 gives us PCl3 plus Cl2 Kc is given at 250 degrees centigrade. On equilibrium mixture at this temperature contain PCl5 concentration of 0.2 and PCl3 is going to be 0.01. Determine the concentration of Cl2 in the equilibrium mixture. Simple. First, what did I say? Write the equilibrium expression. Okay, Dipanshu, write the equilibrium expression. आपको पता चलेगा. Start writing step by step. आज का क्लास क्या? NEET 2026 निर्माण प्रोग्राम, step by step procedure for calculation of the equilibrium numericals. है ना? Yes. So the step 1, start writing the equation, leaving the space for the equilibrium concentration under the formula. So PCl5 gives us PCl3 and Cl2. So थोड़ा सा space निकाल के initially आपको जो जो concentration दिया गया, so आप लिखना पड़ता है बेटा. So 0.2, 0.001 and इसका नहीं दिया, ये निकालना है बेटा. Are you getting or not? Next, write the expression for the Kc step by step, so that it is PCl3 dot Cl2 upon PCl5. Kc value भी दिया गया? Yes, it is. And put these values there, so you have the substituting the values into the expression. Include Kc value is given as 0.19, so that you can have 0.19 is equal to 0.01 into x up निकालना है upon 0.02, 0.20, right? And you can solve x value. Solve the x value is going to get 3.8 mole per liter or mole dm cube. So this is your 3.2 is the answer for this question. Are you getting or not? Are you getting or not? Clear? Bachcho? Fine. Very good. Dipanshu and Deepak Kumar, Mafia, and those who are online, please press the like button. And ज़्यादा मेहनत किया ऐसे लिखने के लिए. Okay. So let us see one more question. We end the session, right? So, ready? Now 6.75 gram of SO2 Cl2 thionyl chloride was put into 2 dm cube. 1 dm cube means 1 liter. Okay, the vessel sealed at the temperature 375 degrees centigrade, and at equilibrium the vessel contains 0.0345 mole of Cl2, and calculate the equilibrium constant for the reaction. It is given SO2 Cl2 gives rise SO2 plus Cl2, and let us follow our steps now. Step by step मैं बोल रहा था. So first we note the number of moles does change. So we will have to calculate the concentration from the amounts. That is the first point, right? And write the balanced equation leaving that room initial concentrations above and equilibrium concentrations below. So SO2 Cl2 gives rise SO2 and Cl2. So above क्या लिखना है, below क्या लिखना. So you are going to write this above क्या लिखना, and amount of SO2 Cl2 mass by molecular mass. Mass is given here 6.75 grams is given, and it is going to be 6.75 इसका molecular mass 135 का है, and it is going to be 0.05, and the concentration mole per volume 0.05 upon 2 liter vessel, 2 dm cube vessel. So it is coming to be 0.025. So you need a lot of patience for that. Okay, and initial concentration of SO2 भी ऐसे लिखना है 0.025 and 00, and at equilibrium you are going to see at equilibrium it is given as 0.0173, and SO2 is going to be जितना Cl2 आता है उतना SO2 भी आता है, and it is going to be the same, and the difference is going to be 0.05 minus 0.0345 comes to be 0.0155, and put that SO, this is number of moles now, mole per liter लिखना 0.00775 is the quantity mole of SO2 Cl2 beta. ठीक है, and you are going to use this. Be careful as you need to working on ratios, that is important, and the balanced equation shows versus that mole of SO2 Cl2 decomposes from 1 of SO2 to gives us 1 mole of Cl2, so that 1:1:1. So that gives rise 0.30345 is to 0.0345, 0.0345. So balanced chemical equation का हिसाब से. Now you can say write this equilibrium concentrations. So once you write this 0.0173, just directly plug into the Kc expression. When you put in the Kc expression, directly you are going to get the Kc 0.0386 आएगा. So that is the same ratio that we have seen. So like that you have various kinds of the calculation strategies, बच्चों, right? The calculation strategies makes you to flourish very glorious in your rank. Try to dream your medical seat and try to just dream your medical rank and to become a doctor, and follow our sessions without fail, and you are going to do the best for your NEET examination. So we are done for today's session. Hope you like this session. Please press the like button and share with your friends, and subscribe to NEET Infinity Learn YouTube channel. Thank you, Deepak Kumar and Dipanshu. Say bye, and we'll meet with more stuff in thermodynamics in next session. Thank you very much. God bless you. See you. Signing off, Suresh, Faculty of Chemistry from Infinity Learn YouTube channel. Okay, thank you.